Today we're going to be taking a look at radical equations and expressions involving radicals of some sort. So the most common way that we're going to see these radical equations is literally with a radical which kind of looks like a square root. It might not be exactly a square root, or we might see something with fractional exponents as well, which we will learn how to change those into radicals, just simplifying those back and forth. But this should be one of the shortest sections we have this entire year, so it should be nice. So, problem 1, please solve the following rational equations, and be sure to check for extraneous solutions. So checking for extraneous solutions means literally plug your answer that you get back in, see if it actually works. Okay, so solving for x, well, the x is underneath the square root, so the first thing I need to do is get that square root quantity completely by itself. So I need to subtract 3, so I should get that square root of 2x minus 3 is now equal to 5. Alright, I've got that square root by itself. So now in order to get rid of that square root so I can get the x from underneath it, I need to square both sides, leaving me with now 2x minus 3 is equal to 25. Because I'd have to square the 5 and I'd have to square the square root. So squares and square roots, they undo each other just like multiplication undoes division. Same type of deal. Solving for x now shouldn't be so bad. So I should get now 2x is equal to 28, solving the algebra step, which is just adding that 3 over. And then divide both sides by 2, I should get x is equal to 14. Alright, so now what I'm going to do is I'm going to go back and I'm going to see, hey, does this solution actually work? So what I'm going to do is I'm going to see my side with my x's only, so I'm looking at this side only. And I'm going to plug in x is equal to 14. So I'm going to say, okay, 3 plus the square root of 2 times 14 minus 3. That's all I'm looking at. And I want to get 8, but if I don't, that means that we got an extraneous solution. So we have 3 plus 28 minus 3, 3 plus that square root of 25, which square root of 25 should be 5. So huzzah, we get 8, so 14 works. Hakuna Matata, no worries. Alright, next one. I'm going to take a look at, alright, on this one I've got 2 x's. So the first thing I want to do is I'm seeing these square roots. That square root part kind of stresses me out. So I'm going to try to get that stuff under the square root all by itself so I can get rid of that. So I'm going to take my 5, add it over, so I should get the square root of x plus 7 is equal to x plus 5 now, adding that 5 over. Alright, I've got my square root all by itself. I need to undo that square root, so I have to square both sides. So squaring both sides. So squares and square roots, they undo each other, leaving me with just x plus 7 on this side is equal to, well, if I've got anything more than just one term, I've got to square the entire thing over on that side. So squaring this entire side, I would actually have that quantity of x plus 5 times another quantity of x plus 5, which means, yeah, we got a FOIL. So we've got x plus 7 is equal to x squared plus 10x plus 25. Alright, from here, now I've got a quadratic. So in order to solve a quadratic, I want my equation to equal 0. So I need to get that x over to the other side and that 7 over to the other side, subtract those over. So I should get 0 is equal to x squared plus 9x plus 18. Alright, from here, I've got a 1, I've got an 18, so I'm looking for factors of 18 that add to 9. So factors of 18 should be 1 and 18, 2 and 9, 3 and 6. Look, 3 and 6 will add to 9. So, again, if you're using guess and check, you can say, okay, what's going to happen is I'm going to have 2 sets of parentheses. I know something times something gives me x squared, so more than likely it's an x and an x. And then my last terms need to multiply to 18 to add to that 9. So I would have 3 and 6. Both of these signs are plus, so both of these signs are going to be a plus. And that should still equal 0. From here, we set each factor equal to 0 to figure out which one could equal 0. So I'd get x is equal to negative 3 and x is equal to negative 6. Again, now I'm going to go in, pick a side, any side, try to simplify it down. So I'm hoping that when I plug in negative 3, so I get negative 3 plus 7 minus 5 should hopefully equal negative 3. Negative 3 plus 7 should give me 4, minus 5 should still hopefully equal negative 3. Square root of 4 should give me 2, minus 5 gives me negative 3, so this one checks out. Cool, cool. Now I check my other solution just in case. So again, I'm going to have the square root of negative 6 plus 7 is minus 5 should be negative 6. So I should get the square root of positive 1 minus 5 equals negative 6. Alright, square root of 1 is 1 minus 5 is equal to negative 6. Well, this isn't a true statement. Negative 5 plus 1, or 1 minus 5, should not be negative 6 unless you've mathed wrong. So in this case, this is what we consider an extraneous solution. Negative 6 does not yield the same thing on both sides. So how I mark this, how I indicate this, is I'm literally going to circle this x is equal to negative 6, and I'm going to put a line through it saying this does not work. And that's it. That's it. Alright, C looks a little tougher because, well, now I've got 2 square roots.